Hey everyone, welcome back to another past paper physics video. Today we're going to talk about the paper 1 question paper from the May-June 2024 and variant 11. Some resources that we are going to be using extensively are the grade booster pack that we have made for the entire A-levels syllabus. This includes the AS definitions and formulae, and this is what we will be using most often. So as you can see, these are reasonable estimates table and common definitions and formulae, important derivations that are part of the syllabus. Some are there as a learning exercise, but most of them have been in the past papers also. Frequently examined questions. Right now, this is more focused on paper 2, but we are working to include questions from paper 1 also, maybe for the next year. Then for A2, a similar document, definitions and formulae, definitions and formulae for all the major, more tested concepts. Then we have important derivations, again from the syllabus and from the past papers. All of them are included. Frequently examined questions for the A2. This is very thoroughly made and checked. So we have syllabus contents on the left side. This and this column are the questions and answers, and the right side are the years. So where you see more years written, that means those questions are more frequently examined. And graphs, we know we all struggle with field graphs, the difference between potential and field graphs. And last but not the least, the planning question from paper 5. It includes a checklist based on the syllabus, examiner reports, and marking schemes, and some worked examples from the October-November 2024. This is 5.1, and the next one is 5.2. Now, all of this is available on Patreon. The link, as you can see below. Go ahead and buy that. This is a very valuable resource. Now, let's see this paper. Which unit is an SI base unit? So we know SI base quantities are length, mass, time, current, light intensity, amount of substance, and absolute temperature. And we also know their units. This is meters, this is kgs, this is seconds, this is ampere, this is candela, this is mole, this is kelvins, sorry, capital K. So base units from this would be ampere. The rest are derived. Which of the following could have the same units as the force? Now, force has the units MA, kg, meters per second squared. So we can compare the base units. However, force can also come from work done also. So force would have the work over displacement. So work is in joules, and this is in meters. So joules, force times by that would be kg meter squared per second squared divided by this. So that would also be force. So again, this is A. The velocity of an object changes from an initial velocity u to final velocity v. Vectors represent these velocities. Which single vector represents the change in velocity of the vector? So basically, the change in velocity is the v minus u. So in v, we have to subtract this. So v minus u is basically going in this direction. So this would be this way. So resultant vector, or v minus u, would actually be this way. So option C. An object is moving with initial velocity u. The object then moves with uniform acceleration a for time t until it reaches final velocity v. Which equation describes the motion of the object? So we have u, we have v, we have a, we have t. The only thing that we don't have is s. So we have few equation. V is equal to u plus a t. The others all include the s. So I think we just need to see which is the rearranged version of this. So u, if you take a t on the other side, this would be v is equal to u plus a t. So this is the answer. Which calculation produces a vector quantity? It produces charge, q is equal to it. Final displacement minus initial displacement is the change in displacement. And change in displacement would also be a vector quantity. So let's keep a pin on this. Work done over time, that is power, that is scalar, times by mass times by speed. This is the kinetic energy, also a scalar. So this is the answer. A thermometer can be read to an accuracy of plus minus 0.5 degrees Celsius. A thermometer is used to measure a temperature rise from 40 degrees to 100 degrees Celsius. What is the percentage uncertainty in the measurement of the temperature rise? Okay, so temperature rise is basically, since you're actually measuring 100 minus 40, but this is the, theta 2 minus theta 1, although this is 100 minus 40, but you have the uncertainty plus minus this involved. So plus minus 0.5 times by 2, because 0.5 plus 0.5. So this would be 60 plus minus 1 degree Celsius. So percentage would be 1 over 60 times by 100. So 100 divided by 60 would be, divided by, so 1.666. So this would be the, this would be the answer. The diagram shows the path of a golf ball. Which row describes the changes in horizontal and vertical components of the golf ball's velocity when air resistance is ignored? So remember, horizontal velocity, we refer to it as Vx. This remains constant, no acceleration. And Vy undergoes the Uy plus At acceleration because there is a downward acceleration at all times. So let's see where we meet. So constant deceleration, horizontal, no, because there is no change in velocity. So these are the possible choices. Now let's eliminate the constant acceleration downward. This is the correct one. This is the correct one. So that's it. Process of elimination, simplest as possible. An aircraft flies from London to Sydney in a time of 21 hours 14 minutes. The distance traveled is 17,000 kilometers. Average speed of the aircraft, they're all given in either meters per second, micro, nano, millimeters per second. So we have to be very careful when dealing with this. So first, let's start with meters per second. So speed would be 17,000 times by 1,000 further to make it into meters. and hours 21 times by 3600 into 21 hours into seconds, and 40 minutes into plus times by 60. So this will all be in seconds. So let's see what we get first, and then we will see. 17,000 times by 1000 divided by 21 times by 3600 plus 40 times by 60, we get 217.94 meters per second. So basically this cancels out this one. Now we need to make it, let's see what we get when we convert it into uh, millimeters per second, or other terms over here. So first thing we can do over here is we need to convert it into standard form. So standard form would be simply roughly 10 raised to power 2 meters per second. Now we can convert it into millimeters, nanometers. So in millimeters per second, this would become 2.2 times by 10. 2 plus 3, this would be 5 millimeters per second. In nanometers per second, this would be 2.2 10 raised to power 2 plus 9, which is going to be 11. And I think we have 11. Okay, that's good. So I think 8 would be C. Just to confirm for the micro also. So in micrometers per second, this would be 2.2 10 raised to power 2 plus 6. That would be 8 micrometers per second. So no, there's nothing there. So the C is the correct answer. All right. Golf club hits a golf ball. The graph shows how the force F on the ball varies with time t. Which graph shows how the velocity v of the ball varies with time t? So the force is basically proportional to acceleration. So if the change in force, so let's look at half of this. So if the change in force is this is constant, that means the change in no wait sorry if this is constant, that means the change in acceleration over time, that is also constant. So if acceleration is increasing, that means velocity will also be increasing for the first half. For the second half, it would be decreasing. So it would have a curved graph. So it will never have a straight line. So 9 would be, first, let's see. Wait a second. Now, out of these two, we have to select which one of them is the right one. Now, when you have an increasing gradient, you see the gradient is decreasing in this. But in this one, the gradient is increasing and then it decreases. So B would be the right answer according to this reasoning. So first the acceleration is increasing, then the acceleration is decreasing. What is meant by the mass and the weight of an object on Earth? Mass is the quantity that resists motion or acceleration. Weight is the pull of gravity on the object. So momentum divided by velocity, gravitational force on it, definitely no. Pull of the earth on it, no. Property that resists is acceleration. I think this would be the only thing. Yeah, so yeah, that's it. Right, a thin horizontal plate of area 0.036 meters squared is beneath the surface of a liquid of density this. The force on one side of the plate due to the pressure of the liquid is this. What is the depth of the plate beneath the surface of the liquid? So basically they're saying that the plate is this, and we need to find out the depth or the height. The force is given due to the pressure, and the area is also given, right? So basically we know that force is equal to pressure times by area, and pressure, since due to the column of a liquid, is rho g h a, and a is the cross-sectional area. H is what we just simply need to figure out. We have the force, we have everything. So H would be force over rho g a. So force is given as 290, rho is 930, g is 9.81, and cross-sectional area 0.036. So 290 divided by 930 divided by 9.81 divided by 0.036. Oh, sorry, 36. So 0.882. So this would be A. Spheres X and Y form an isolated system. Mass of Y is greater than the mass of X. So first let's write this way. Sorry, X. Sphere Y is initially stationary, so Uy is equal to 0. Sphere X collides elastically with sphere Y. That means the total kinetic energy before and total kinetic energy after is the same. Speed of sphere X before collision is U. So Ux is basically U. Which statement must be correct? Alright. Sphere X rebounds with a speed that is greater than U, and sphere Y moves off with a speed that is less than U. Sphere X rebounds with a speed less than U, and sphere Y moves off with a speed that is also less than U. Right, okay, so we can actually see this over here. So we have mx ux plus my uy equals to mx vx plus my vy. So mx ux is basically, we don't know the, we don't know, no, we do know that. Okay, so mx u, and this is initially stationary. So the entire momentum is coming from the previous momentum, or the momentum before of the sphere X. Mx Vx plus My Vy. Okay. Now, according to this, the momentum that was before is distributed in the momentum after. So both of their speeds will be less than u by default. So option B. A ball of mass 0.10 kg is thrown towards a stationary vertical bat. The ball hits the bat with a horizontal velocity of 20 meters per second. The ball rebounds and leaves the bat with a horizontal velocity of 15 meters per second. So basically that means the final velocity is 15 meters per second in this direction. What is the change in momentum of the ball? So change in momentum, remember, since the final velocity is in the opposite direction, and let's take this direction to be positive, this would be v minus u, because 20 is in opposite direction. So this would be 0.10 times by 15 plus 20 minus 20 basically. So 0.10 times by 35. So sorry, I did the calculation in my head basically. So 0.1 times by 35, that would be 3.5. Yeah, that is it. All right. All right. An isolated object of negligible weight is acted on by two coplanar forces of the same magnitude, in which diagram is the object in equilibrium. So remember, for equilibrium, we have two conditions. Sum of forces in any direction is zero, sum of moment about any point is zero. So if we look at A, these forces are basically opposite. So this is F, this is F. So sum of forces is definitely equal to zero, but they're also allowing no moment to be produced either, because their line of action of forces are aligned. So sum of moments will also be equal to zero. But if you look at on this side, the forces are in opposite directions. Okay, resultant force technically zero in any direction, zero, but they are separated by a distance. That means this will create a couple. So so equilibrium will not be attained. This has forces in one direction, so resultant force will not be equal to zero. Same way, the forces resultant force would be in this direction. So A would be the correct answer. A uniform beam PQ rests horizontally on a support at point S. A rope is attached at one end of the beam. Rope is at an angle 60 degrees to the vertical and exerts a force F in newtons on the beam. What is the moment in Newton meter of the force F about the point S? So we know that this component of F will not be exerting the moment because this is basically uh, passing through the center. The line of action of this component will be passing through the center, so this will not exert any moment. But however, this moment that is perpendicular to the this line of action of force, this would cause a moment. So this component is F cos of 60, and the difference or the perpendicular distance between the line of action of force and the pivot is 2.5 minus 0.3, basically 2.2. So moment, sorry, not sum of moment, moment of force F would be F cos of 60 times by 2.2. So 2.2 times by cos of 60 is 1.1. So F times by 1.1, so that would be A part. Right. The diagram shows the dimensions of an elastic cord used to project the stone. The tension in the cord is T when the cord is pulled into the shape shown. Which force does the elastic cord exert on the stone? So that means the net force that is exerted over here, that is caused by these components of T, T cos of, let's call this angle theta, T cos theta, and this T cos theta also. So basically the net force would be 2T cos of theta. We need to find out cos of theta. So if you notice one thing, this is 6 centimeter and hypotenuse is basically 10. So cosine is adjacent over cos. So cos theta is basically 6 over 10 already. So 2 times by t times by 6 over 10. So 12 over 10t. So this would be 2 times by 5, 2 times by 6. So 6 over 5t, which is B part. Now, a box of weight 40 newtons is pushed with a horizontal force of 20 newtons along level ground for a distance of 2.4 meters. That means in this horizontal direction 2.4 meters. The box is then lifted at a constant velocity through a height of 1.6 by a vertical force. Constant velocity. All right. So what is the total work done on the box by the two forces? So remember, the total work done would be involving the horizontal work, force times by displacement, plus the work done against gravity, weight times by height, 40 times by 1.6. So 20 times by 2.4 plus 40 times by 1.6, 112 So in 112, oh sorry, this would be correct because this is the same answer up to two significant figures. Which statement about efficiency is correct? Does not have a unit. That is correct. So that's the first option. We don't even need to look at the rest. A plane wave of amplitude A is incident on a surface of area S placed so that it is perpendicular to the direction of travel of the wave. Energy per unit time reaching the surface is E. Amplitude of the wave is increased to 2A and the area of the surface is reduced to half S. How much energy per unit time reaches this smaller surface? Now, energy per unit time, that's basically power, and this is area. Let's call this area S anyway. So we know the intensity formula. Intensity of a wave is power over area. So, and we also know that intensity is proportional to amplitude squared. So if amplitude has been increased to 2A, intensity would be 4 times by the previous intensity. So if I1 is first energy per unit time power over area, E over S, I2 would be 4 times by I1. However, I2 is, which is 4 times by I1, is going to be equal to some energy, let's call it E2, and half S. Now we need to isolate or make E2 the subject. So E2 would be 4 times by I1, which is E over S, times by half of S. Just simple cross multiplication, nothing more. So half cancels out with, sorry, S cancels out with this, half times by 4 is 2. So this would be 2E as it is. Right. A steel ball is falling at constant speed in oil. Which graph shows the variation with time of the gravitational potential energy EP and the kinetic energy EK of the ball? Now, notice one thing over here, that the change in gravitational potential energy is reflected in the change in kinetic energy plus work lost or energy lost or work done against the viscous forces. So basically you can say that the work done against work against viscous forces. So the EP, so at constant speed, sorry, if it's falling at constant speed, EK would be constant. So between A and B, we have to decide. But the EP will not be EP. So if it's falling at constant speed, so that means the change in height, so constant speed means S over T, or basically height over T in this case. So mgh part over here, that is also decreasing at the same time, at the same uniform form. So I think B would be the correct one. Why? Because again, if speed is constant, height is speed times by T, so that would be the same thing, right? So it would be a uniform decrease. B. When a force of 0.8 newtons is applied to a spring, the length of the spring is 90 millimeters. When a force of 1.3 is applied to the same spring, the length is this. Spring obeys Hooke's law. What is the spring constant of this spring? All right, so remember one thing, we can try this with two things. First off, we need to represent this in terms of extension. So this is length 2, which is the extension plus the original length. We don't know the original length. This is the new length simply. We need to represent this in terms of the extension. So F1 is equal to K times by L2 minus L. Let's call this L1. L1. Sorry, let's call this L1, and this is the original length. And the F2 K remains the same, and L2 minus L0. So F1 is 0.8 newtons, K, which is a constant, L1 minus L0, so spring length is 90 millimeters, and we need to represent this in meters. So 90 millimeters, so 90 divided by 1000. So simply, basically 0.09 minus the original length. Then we have 1.30 K. This is going to be 115, so 1.15. No, sorry, 0.115. And minus L0. Because 115 divided by 1000, that is 0.115. Right, okay. So both of these are the unknowns. We need to solve them in a way that we get the constant. So we need to make K the subject rather than L0. So how do we do this? So what we can do now is so we can represent both of them one by one in terms of L0. So because we need to make L0 the subject. So this would be 0.8, the first one, divided by K equals to 0.09 minus L0. So L0 would be 0.09 minus 0.8 over K. The second one would be L0 equals to 0.115 minus 1.30 K. Now, just to make sure that we got it correct, otherwise we'd have to do this again. All right, now we equate these two. So 0.09 minus 0.8 over K equals to 0.115 minus 1.30 over K. Now we make K's term on one side. So 1.3 minus 0.8 over K, 0.15 minus 0.115 minus 0.09, 0.25, and K goes on the other side, so this would be 1.3 minus 0.8 divided by 0.025. So 1.3 minus 0.8 divided by 0.025, this is 20. So 20 d part. Right. Right. An experiment is carried out using a metal wire to investigate how it responds to a varying tensile force. The cross-sectional area of the wire is constant. How it responds to varying tensile force. Okay. Which graph has a gradient that is equal to the Young modulus of the metal? So Young modulus, remember, that is the ratio between stress over strain. So stress over strain basically is the C option. Right. Okay. Where did the mouse go? Right. For a wire, Hooke's law is obeyed for a tension F and extension X. The Young modulus for the material is X, which expression represents the elastic potential energy stored in the wire. Basically, that would be the area under the Fx curve. So half times by Fx. Simple. A plane polarized wave has an amplitude A. The wave is incident normally on a polarizing filter. The transmission axis of the filter is at an angle theta to the plane of the polarization of the incident wave. What is the amplitude of the wave that emerges from the filter? So first off, that we have I naught cos square theta. This is the Malus law. So first off, we can get a description in terms of intensity. So we know intensity is proportional to amplitude squared. So if this is the case, we would actually get in the form of amplitude squared. Simple, 20 squared. This would also be squared. So amplitude itself would be square root of both A naught cos theta. So A part. An electromagnetic wave is traveling through a vacuum. What could be the wavelength and period of the electromagnetic wave? So remember, the speed is basically 310 raised to power 8 meters per second. So, and we also know that V is equal to F lambda, but F can be represented in terms of time period, so lambda over T. So the ratio of lambda over T should be 3. So tera is 10 raised to power 12, and mega is 10 raised to power 6, giga is 10 raised to power 9, pico is 10 raised to power minus 12, nano is 10 raised to power this. Okay, so let's see this. 1.2 10 raised to power minus 10, tera 12, and 2.5 mega, so 10 raised to power 6. Similarly, let's try with this one. So 1.2 pico, so basically that's minus 12. 2.5 10 raised to power 11, and giga, that means 9. Oh, sorry, plus, my bad. Okay, that's not either. So, all right, let's try the third one. So the 10 raised to power 2, pico. So 10 raised to power 2 minus 12. And for this one, we have 4. Oh, sorry. Oh, we have 4. Okay, 4. 4, 10 raised to power minus 10. And nano, so also minus 9. Oh, this is 2 and 6 zeta. So that is the speed. So that is C part. Light of frequency 6.7 10 raised to power 14 hertz in a vacuum is incident normally on a diffraction grating that contains 4 10 raised to power 5 lines per meter. What is the angle between the adjacent second and third order intensity maximum. Okay, so first off, we need to convert this into the distance between this. So 1 meter for 10 raised to power 5 lines. So 1 divided by 4 divided by 10 raised to power 5. So this is this value. Let's convert it into standard form. So standard form would be this. 2.5 10 raised to power minus 6 meters. So we need the thetas between the second and the third. So n lambda is equal to d sine theta. So for order 2, lambda is, light. So that would be v over frequency. So 3 10 raised to power 8. Frequency is 6.7 10 raised to power 14. Divided by d. D is this value, 2.5 10 raised to power minus 6. This would be the sine theta for order number 2. And for the order number 3, this would be 3 10 raised to power 8. 2.5 10 raised to power minus 6. And frequency remains the same. 6.7 10 raised to power minus 40. Right. So 2 times by 3 times by 10. Let's just do sine inverse right away. So 2 times by 3 times by 8, 10 raised to power 8, divided by, divided by, let's do the numbers first and then powers of 10, divided by 2.5 divided by 6.7 times 10 raised to power 8 plus 6 because minus and minus 14. So the first one is 20.99 normal mode. And once we do the 3 for the third order, this is going to be 32.5. So 32.5 minus 20.99. So 32.5 minus 20.99. That is 11, roughly 12. So this would be the answer. The siren of a moving police car emits a sound wave with a frequency 440 Hz. A stationary observer hears the sound 494 Hz. Speed of the sound in the air is 340 meters per second. What could be the speed and direction of the movement of the car? So first off, frequency is increased. So observed frequency is increased. So that means it is coming towards the observer. So this cancels out, this cancels out. So we need to see this. For this, we can actually go through to see the Doppler effect formula. So Doppler effect formula. So let's see. Actually, that's very easy to remember, but you can actually see that how we can actually use this. So Doppler effect. Okay. So approaching source V over V minus Vs, where F naught is the observed frequency, Fs is the source frequency, V is the speed of the wave, and Vs is the speed of the source. So we have F naught equals to V over V minus Vs F. We need to figure out Vs. So F naught observed is 494 over F is 440. So V is 340. 340 minus Vs. So first off, we cross multiplies 340 minus Vs is 440 minus 340 divided by 494. So we have 440 times by 340 divided by 494. That is this value. And Vs would be 340 minus whatever the answer is. So this 340 minus answer, this is going to be 37. So 27 would be B, towards the observer. All right. The diagram shows the shape at one instant in time of part of a stretched string as the wave travels along it from left to right. What are the directions of velocities of points 1, 2, and 3 on the string at this instant in time? Now, stretched string as a wave travels along it from left to right. Okay, so if it is moving from left to right, this point would be going downwards. This point would be going upwards. And since basically what is going on that this crest is moving this way and this trough is moving this way, so this point would be coming down. So down, up, down, down, up, down, D part. Which wave cannot be a longitudinal wave? And this is a very simple wave, a polarized wave, because polarized wave is always a transverse wave. That is one of the distinguishing qualities of transverse waves. Microwaves are emitted from two sources at points X and Y. Two waves meet at point Z, and the diagram shows paths of two waves. Waves emitted from points X and Y are coherent. What is the direct consequence of two waves being coherent? So coherence basically means constant phase difference. So if you want to see that, coherent, oh sorry, actually this would be over here. Yeah, constant phase relationship, constant phase difference. So there's a constant difference is phase between the two waves at Z. So B part. What is the unit of resistivity? So we know resistance is equal to rho L over A. So resistivity is R times by A over L. So R is ohm, area is meter squared over M. So this would be ohm meters. 31D. A kettle is connected to a 250 volts main supply. What are the possible values of the power of the kettle and the current in the kettle? Now, remember, kettle is a heating device, so it will have a higher current. So 10 ampere is usually a right answer. So maybe I think kettle would be a reasonable estimate of kettle current. Maybe we have that. Let's see whether we have or not. So no, sorry, current. Do we have current over here? We don't have current, but okay, that's a surprise. Resistivity, temperature, resistance, power. Okay, so you see power around 2 kilowatts. Actually, this is a very reasonable estimate. You can even see that at your home. So roughly around 2000. So if you multiply this, you will actually get 25,000. Oh, sorry, my bad. Sorry, my bad. This is the 2500, so the 2.5 kilowatt. So The tie is between these two, so kettle are heating devices, so they have high current. So D would be the right answer. Which circuit results in output voltage V out increasing with increasing temperature? So remember, with increasing temperature, the thermistor uh, resistance decreases. So if that decreases, the potential difference across this would also decrease. So V out increasing. So it should be on the other one. Yeah. So potential difference across this would decrease. So potential difference across the constant resistor would increase. This is just potential divider formula at play over here. Four resistors, each of resistance R, are connected as shown. The total resistance between point X and point Y is 120. What is the magnitude of resistance R? Okay, so remember from this path, you have 3R resistance. So 1 over effective resistance, that is going to be 1 over R plus 1 over 3R. So this would be 3 over 3. So 4 over 3R. So effective resistance would be 3R over 4. And if this is equal to 120, so R would be 4 times by 120 divided by 3. 3 times by 40, so 4 times by 40 is 160. Simple math over here, nothing more. A cell with internal resistance is connected to a variable resistor R as shown. The resistance of R is gradually decreased. How do current and terminal potential difference across the cell change? So terminal potential difference, terminal PD, is actually equal to the EMF minus lost volts. So IR equals to EMF of the cell equals to the IR. So if you are decreasing the R, basically, if you're decreasing the potential, so if E is the only thing that's not changing, right? So this would be R plus R. So E is the same, R is being reduced. So IR plus IR E. So this means that if R is being reduced, terminal potential difference would decrease, lost volts would increase to maintain the constant EMF, which would mean that the current is increasing. So current is increasing, so it could be this and this. Terminal potential difference would decrease. We said that, so that would be C. The diagram shows a circuit with a cell and 3 resistors with resistances R1, R2, and R3. The cell has negligible internal resistance. What is the total resistance of the circuit? The total resistance of the circuit is RT. Which equation for RT is correct? So this is R1 plus R2. So 1 over RT is 1 over R1 plus R2 plus 1 over R3. No, no, no. This is correct. Hydrogen and deuterium can be represented by nuclide symbols H11 and H21 respectively because of an extra neutron. What is the difference between hydrogen and deuterium? One more neutron. Deuterium atom has twice the number of electrons. No, no. Deuterium nucleus has a charge, but no. Less mass than hydrogen nucleus. No. Has half the charge per unit mass of the hydrogen nucleus. Charge per unit mass. That would be true because charge is the same, Q, basically 1e, 1e. So for H and for deuterium, you have charge E because one proton, but mass is twice. Sorry, U mass for one proton and 2U for that. So basically half the charge per unit mass. A radioactive sample decays by emitting beta negative particles. The energy released in the decay process is the same for each nucleus that decays, but the beta negative particles emitted have a continuous range of kinetic energies. Right, okay, which statement explains why the beta negative particles are emitted with a continuous range of kinetic energies? The reason behind that is that it has to share energies with antineutrinos. So given to remaining nucleons, no. Um, Release is taken by an emitted antineutrino. This would be the correct one. Which particle is not a fundamental particle? So fundamental particles involve quarks and leptons. So electron is a lepton. So cross neutrino is a quark is a, sorry, neutron is a combination of quark, a hadron. This is not a fundamental particle. What is the charge on an anti-top quark? So remember, the charge is over here. So it's easy to remember the charges basically, but if you forget, up charm top have positive plus 2 over 3e. So the anti-top would have minus 2 over 3. We have anti-top, right? Yeah. So minus 2/3 of e. And that's it for this paper. Hope you all learned something. If you feel that I wasn't able to explain a certain question properly, do reach out in the comments. I will try to explain it. And do check out this great booster pack. This is an insanely powerful resource that we have developed. As you can see, I've already shown you what files it contains. So it's going to be very useful for your exams. All right, so see you in the next video. Bye bye.